All right, today we're going to pull back the curtain on something we've all played. We're going to deconstruct a simple mobile basketball game, diving right into the code and the physics that make it tick. You know, how that simple flick of your finger actually becomes a perfect swish. Let's get into it.
Yeah, we've all been there, right? Mindlessly flicking a virtual basketball, trying to get that high score. But have you ever actually stopped and wondered what's happening under the hood? How does the game turn that simple touch into a realistic physics-driven throw? Well, that's exactly what we're going to unpack right now.
So here's the game plan. We're going to follow a single shot from start to finish, breaking it down into 5 key parts. First, we'll set up the virtual court. Then, we'll look at how the game actually captures your swipe. After that, we dive into the real physics of the throw, see how the game predicts the arc, and finally, figure out how it knows if you scored, missed, and how it resets for the next shot.
Okay, first things first. Before we can even think about shooting, we've got to build the court, right? This is all about understanding the basic pieces that make our game world work.
So the whole show is basically run by 3 main C# scripts, and each one has a very specific job. You've got the BallThrower, which you can think of as the star player. It's handling all your input and the actual physics. Then there's the ScoreGate trigger. That's our referee. Its only job is to watch if the ball goes through the hoop. And finally, the GameManager, well, that's the coach, keeping score and running the game from the sidelines. Now, these scripts need things to control. So in our game scene, we have a few essential objects. Of course, there's the ball itself, and it has a Rigidbody component. Now, that is absolutely crucial. It's basically you telling the game's physics engine, hey, this thing, it's a real object. Make gravity and forces work on it. We also have a specific spawn point for the ball, the hoop ring, which is our target, a line renderer to draw that handy guide path, and finally, the game manager to oversee everything.
All right, court's ready. The pieces are in place. Now we need to actually listen to you, the player. This next part is all about how we capture that swipe and turn a physical motion into cold, hard data the game can understand.
The whole thing breaks down into 3 simple steps. It all starts with start drag. The second your finger touches that screen, bam! The game logs that starting point. As you move your finger, continue drag is firing constantly, tracking where you are in real time. And finally, the moment you lift that finger, end drag is called, and that's the green light to launch the ball.
And believe it or not, this one little line of code is the absolute heart of the whole input system. The game just takes your final finger position and subtracts your starting position. That's it. The result is something called a swipe, and it tells us everything we need. But what exactly is this Vector 2 thing anyway?
Yeah, vector sounds kind of technical, but don't worry. It's really just a way to package up 2 bits of info into one thing, a direction and a length, or what we call magnitude. So for our swipe, this one single value tells us both which way you swiped and how far you swiped. It's literally the blueprint for our entire throw.
Okay, now for the really cool part. We've got our data, that vector we just talked about. This is where the magic happens, where we take that blueprint and hand it over to the physics engine to create an actual moving basketball. So how does your swipe translate to the throw? It's actually super intuitive. The length of your swipe, its magnitude, becomes the power of the shot. You make a longer swipe, you get a more powerful throw. Simple as that. At the same time, the vertical part of your swipe, its Y value, controls the arc. The higher up you swipe, the higher the ball is going to go. So how does the code turn that raw swipe length into a nice, clean power value? Well, it uses this super handy function called Lerp, which is short for linear interpolation. The best way to think about it is like a dimmer switch. We set a minimum power and a maximum power. Lerp then looks at your swipe strength as a percentage, from 0 to 100, and finds the perfect power value in between our min and max. This keeps every shot feeling balanced, never too weak and never totally overpowered. But here's the clever bit. The direction isn't just your swipe. The code is smart enough to first calculate a base direction pointing straight for the hoop. Then, it blends in that upward boost that you gave it with your swipe. This gives us the best of both worlds, a reliable aim toward the target mixed with your skill in setting the arc. Okay, before we actually launch the ball, let's talk about one of my favorite features, that little dotted guideline that shows you the future, showing you exactly where your shot is headed. This isn't magic, it's just more physics, all calculated before you even let go. So, what's the secret? How in the world does it know where the ball is going to go before you even shoot? Well, while your finger is still on the screen, the game is constantly running a mini simulation in the background, predicting the path based on your swipe at that very moment. Let's see how it works. To predict the future, it just uses a good old-fashioned projectile motion formula. You just need 3 key ingredients:
the initial velocity, which is just the power and direction we've already figured out, good old gravity, that constant downward pull, and time, which lets us plot out points along the path.
And this is it, the formula right from the code. I know, it looks a little scary, but the concept is simple. The game just runs this calculation over and over super fast. For the first point, t is a tiny fraction of a second. For the next point, t is a little bigger, and so on. It does this about 25 times to generate a whole series of points, then it just connects the dots to draw that guide path.
And finally, after all that calculation, the moment you lift your finger, boom, this is it. This single command, AddForce, is the grand finale. We feed it our final direction and power and tell the physics engine, go! The ball is now officially on its way.
Okay, the ball's flying through the air, but we're not done yet. The game still has to figure out what happened next. Did you score? Did you miss? And what do we do now? This is the final piece of the puzzle.
You might be wondering, how does it know you scored correctly and didn't just, throw it up from underneath? Well, it uses this really clever two-gate system. There's an invisible trigger just above the rim and another one inside the hoop. For it to count, the ball must pass through the top trigger first. When that happens, it flips a switch, setting a little flag to true. Only then, if the ball passes through the bottom trigger, does the game say, yep, that's a legitimate score.
And this is where our coach, the game manager, steps back in. It's the brain of the whole operation, and it's keeping track of everything. It updates the score, it tracks how many balls you have left, it decides when the game is over, and it puts all that info up on the screen for you to see.
So whether you get that satisfying swish or, you completely brick it, the outcome for the game logic is the same. After a short pause, a function called ResetBall gets called. It just zaps the ball right back to its starting position, resets all its physics, and gets everything ready for you to take your next shot. And that completes the loop.
So there you have it. We've gone from a simple swipe to a perfect swish. But here's the thing. These ideas, capturing an input, turning it into force, predicting a trajectory, they're not just for basketball games. They are the fundamental building blocks for tons of other mechanics. Think about it. Angry Birds, paper toss games, catapults. It's all the same core idea. The only question is, what would you build with it?